Hello everybody. How is it going? How's your Saturday going? Welcome everybody to the stream. How is everybody's Saturday going? It's a beautiful Saturday today. It was a pretty chill Saturday. Slept a lot in the afternoon and had some work in the morning. Slept a lot in the afternoon and evening. Tonight I have some plans after 9. I have a dinner planned. So I thought, what's better? How do I spend the evening? I'm alone right now. And what do I do? I thought, okay, let's do some algorithms. Quick and easy, or maybe not, maybe hard, right? Yeah. So how is everybody's Saturday going? How's it going? We are gonna start streaming in about 2 minutes. Setting up stuff. Okay, cool. Okay. Yeah, I think it's 6:46, and probably I'll stream for 1.5 hours or 2 hours max. So let's get started. It's already 15 minutes to 7. Cool. Time to switch to live mode and start grinding some code. Okay. Let's do some maths today. Let's start with some maths. Armstrong number. Okay. So given an integer n, return true, and if and only if it is an Armstrong number. The k-digit number n is an Armstrong number if only the kth power of each digit sums to n. Okay. So anyways, you can max go up to 2 million or billion. How is it? I think it's 2 billion. Yeah, it's 2 billion, right? I mean, I did 2, so that's wrong anyways. So, but anyways, that's fine. 1 2 3 1 2 3. Wait. It's 10. So million is 6. Then there is 3 more. So yeah, I think it's 2 billion, if I'm not wrong. Anyways, I'm too poor to understand so big numbers, okay? So very poor to actually comprehend these big many numbers. Anyways, it's a very easy problem, so let's quickly solve it. So this is saying that integer is n, return true only if it's an Armstrong number. When it's an Armstrong number, when the k-digit number n is an Armstrong number if and only if the kth power of each and every digit sums to n. That's pretty much it. We can simply iterate over the entire digit twice and sum it up. So it's 1134 I'm gonna zoom a little bit. Okay. I hope the music is not too loud today because I realized from my last stream the music is very loud. I don't want to bang anybody's ears, so might go down a little bit more. Just let me know in the chat if the music is good and the voice. Okay. So private int digit. Let's call it a length, right? Int n. And since it's not a reference, we can easily work with this. So int length is 0, while this thing length is this, n is this. Return length. Okay, so find length of n. So here is this, int temp is 0, int x is n. Okay, while x is not 0, what are you gonna do? You're gonna simply say the matplow. I think there is a thing like that, so I'm just gonna use this for now. So the digit is basically x mod 10. So you have the digit and then you have length, and let's call this k for now, so it's more aligned to what we're doing. All right. Sorry. So this is this. So this is this. After that, you are simply gonna say, well, of course, it has to be an int. Okay. Return. Yeah, that's basically it. It should be as simple as that. Hopefully, I didn't mess up anything, and that is the solution. Okay, that seems to work fine. Okay, cool. Cool. Okay, that works. Did I solve it before? Apparently not. So another one. Count substrings with only one distinct letter. Count substrings with only one distinct letter. Given a string s, return the number of substrings that have only one distinct letter. Okay. So 1, 2, 3. So for this, right, you will have this. So the entire like each and individual characters, the length would be the first answer. Oh. A, 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 B, A. So length has to be the answer. That's one thing. After that, we have to find out. So as an example, this is 1. Then this we already considered, and this we already considered. So length plus 1, which is 5, in this case 6. So I think it has to be 6. It is 8. Aha, because this is also considered as having unique letters, single unique letter. So this 2 would be here as 5 plus 1, 6, plus 2, 8. That makes sense. Yeah. So the very simple answer here is that we can iterate over every substring, and that would be an n-square solution, and we then iterate over every substring to find out if it's a single character or not. Okay, so if it's a single character or not, we can do that. Yeah. So that would be almost n-cube solution. We can see what is the, okay, the length is maximum 100,000. So this would basically become 10 to the power 3 into 3, so 10 to the power 9. This is a billion operations, which shouldn't be a problem for your modern CPU, I think. But yeah, maybe it becomes slow. Maybe it becomes slow. Not quite sure. Not quite sure if it becomes slow. Just a second. Cool. So the question here is, what do we even, how can we even try and optimize it, at least come down to n square? One of the things I want to do here is that time complexity with constants. So I feel this is a more relevant thing. So if it's, yeah, so if it's less than or equal to 500, then n cube is okay. So for us, it's 10 to the power 3. So maybe n squared is something that we have to settle for. N squared is something that you can settle for easily, I feel here, because n squared is for generating all the substrings, and then n is basically for figuring out if they have unique listing. But what we can do is, I feel, we can simply say that, we can simply ignore this n and kind of figure out within the certain loop, within the inner loop, that if it is a substring of that, right? So what we can do, I feel, is the next best solution, I feel, is what we can do is A, B, A. So what we can achieve here is that we have this guy, this guy, this guy. So we can start. So let's think in this way, that I always choose a starting point, and from there I go on the right hand side. Because I will be iterating over one by one, I can always consider that like I'll always go on the right. I'll always expand on the right. It's not a palindrome thing where I'll try to expand on both sides, right? So that's one thing. So we try and expand on the right hand side. And we expand till we I'm sorry, till the character is same as this. So that's an n square solution, because for every single point you try and expand on the right hand side. So till here you would kind of, your inner loop would kind of stop here, right? Your inner loop would kind of stop here. In fact, I think you can do a single this thing, because all you have to find is the stretch. All you have to find is the stretches with which has the same characters. So if you have your cursor in here, you can move here. It's the same. So when you move here, so your start was 0, or your end is basically 1, 2, 3, 3 minus 1. Now the length is 3 minus 0, so 3. Now we can simply do a match to figure out how many number of substrings are there for length of this thing, right? So we can check that. When it's 1, it's 1. When it's this, then it is 1, 2, 3. A is basically 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Right. A is 1, 2, 3, 4. Plus, if you group 2 of them, so it will be 3. If you group 3 of them, it would be 2. Then you have the entire thing, which will be this. So 7 plus 10. Okay. So do we have a pattern? It's 1, 3, 6, 10. Look at that. Do we have a pattern, buddy? Well, it's this, right? So it's just summation of that number. So it is n into n plus 1 by 2. That's all. Well, that also makes sense, because if you have x number of characters of length, right? So let's do it this way here. So if you have a string which is of x length, then each and individual characters, like length of 1 would be, substrings of length 1 would be x. Substrings of length 2 would be x minus 1. Substrings of length 3 would be x minus 3, and accordingly you would then go back to 1, which is the length of x, right? So this is what, which is basically summation of n, x is 1 to n, which is n into n plus 1 by 2. We can quickly check if that is correct or not. Well, 1 to 1 into 2 by 2 is 1. Then for 2, it is 2 into 3 by 2, which is 3. Then for 3, it is 3 by 4, so it's 6. Sorry. And for 4, it's 4, 5, 2, 2, 10. So that is correct. So we're going to do the solution. And it's going to be O of n solution. Okay. 1180. Cool. Sounds cool. Sounds pretty cool to me. 1180. Is that what you? 1180. Okay. And it should be fairly fast for like 1000 input. We could have still gone up to like n square and square log n and things like that. But yeah, we kind of solved it in O of n. Yeah, we solved it in O of n because here also we don't have to iterate over the numbers to get the sum. You simply do a maths. That's all, right? That's all. Okay. Int cursor is 0 while cursor is less than this. So why do you refactor it like this? I don't understand, buddy. Like int length is this. Okay, so now int start is current. Look at that. Can you do it? Holy shit, it can actually do it. So current is less and this is this. Okay, so what you do is current plus plus. Good. So whenever you actually go out of your scope, what you simply do is current minus start int n equals current minus start. Okay, so n into n plus 1 divided by 2. Total plus equals this. Int total is 0. You can simply return total. Also, I don't like total. I think it's count. Awesome. Wrong answer. It's 32. What the fuck? It's the fuck just happened? Okay. That is correct. That's the entire length. That is entire length. So length into, yeah. Ah. I think my braces are yeah. So my implementation of this was wrong. Not the logic. Cool. Guess the majority in a hidden array. Okay. We have an integer nums where all the integers in the numbers are 0 or 1. You will not be able to do a access array. Instead, if you have an API reader, which has the following functions. You query ABCD. Okay. So you basically give it 4 indexes. The function returns a distribution of the 4. of the 4 elements and returns. The 4 means if the values of the 4 elements are same, if 3 elements have a value equal of 0 and one element has, or vice versa, okay? If two elements have a value equal to 0 and 2 elements have a value equal to, and int length returns the length of it, okay? Also in Java, it has actually written CPP code. Very nice. You're allowed to query 2 into n times, where n is equal to the length. Return any index. Return any index of the most frequent value in nums. Okay. This motherfucker is a problem. Okay, so you can query A, B, C, D. Okay, you can just pass in 4 indexes and it would give you back the distribution. So if it's 4, it basically means that 4 of the elements are the same, but it can be either 0 or 1. If you give 3 elements, if you have 2, it means 3 elements have the same value. If you get back 0, it means it's equal distribution, 0 and 1, but you never know which is what. Who came up with this motherfucking question? Any companies who asked it? Google asked it 6 months back. Of course, Google. Of course. Okay. I hope the stream is okay. So since I got a new Wi-Fi adapter, the stream has not been going down. Like the internet has been quite stable. So I kept on talking about Airtel, but it was my Wi-Fi adapter on the CPU, the inbuilt adapter, which was stupid. Anyways, they still deserve bashing because mobile internet is still shit. But anyways, back to the problem. Okay, so length gives you back the length, and okay, okay. Length is 10 to the power 5, so my maximum time you can call them as 2 into n times. Okay, so it is like an O(n) solution that you can do, but you can still call it like 2 into 10 to the power 5 times. Okay. Return any index of the most frequent value in nums. This is a more probabilistic, right? Because here, like, it just feels like from a mental model, what you can do is you can query one by one, and you can say if this is 0, this is 1, and you can try down both the branches, and at certain point there'll be a conflict, like how you do Sudoku. And at some point you might say, oh, this is a 0, and accordingly you go up the tree and say, oh, this box is 1, this box is 0, this box is 1, right? So it's similar to Sudoku, but I don't know how to programmatically solve that. And yeah, maybe let's try to just do it by hand, and usually visualization kind of simplifies the problem. Sorry. So length here is 3, 4, 5, 5, right? So the very first thing I can do is, since length is 5, I can say give me 0, 1, 2, 3. give me all of them. So in this specific case, 0, 1, 2, 3, they're gonna give me 0. So for me, it can be 0, 0, 1, 1, 0, 1, whatever. Like it's a equal number, right? So in here, the biasing is no one, -1, because both of them are equal in this particular range. Hold on just a second. There's someone at the door. People keep on coming. Just give me a second. I will be back. Ah, Okay, I'm back. So I realized two things. My own voice is very, very loud. So I'm going to take that a little bit. And the music is very low. So I'm going to take that up a little bit. I hope now my voice and everything is okay. And it doesn't blast your ears. I'm really sorry. If anybody is watching me live right now, if you can confirm on the chat that you can hear music and I'm not blasting your ears, okay? Okay, back to the problem. Okay. So yeah, what was the problem again? So it's majority element in an hidden array. So you cannot look into an array except for an API. And what all you have to do right now is, okay, so you can query and then it returns back certain things. So 4 is all the 4 elements are same, but it doesn't say what. If 3 elements have a value equal to 0 or vice versa. So basically 3 elements are same. And then for 0, it basically means that if 2 elements have the value of 0, okay? 2 elements have the same value. Just wait a second. Just give me a second. I have this. Shit. Cool. Question is, how do we even do this? So let's look at the hint, because I have nothing going on. If you find that 2 indices in the array have the same value, you could infer the values of x and y based on the results of because so we don't have to return the majority element, we have to return the index which has one of the majority elements. So we have, if 0 was more, yeah, okay, so that makes sense, because if 2 indices we can find which is of the same this thing, we can now start comparing it with other indexes. So let's say, let's take this example and do it, right? So since the length is 5, I can 0, 1, 2, 3. And in here specifically, it would come out as 2. Sorry, it would come out as 0 because 2 elements are same. It would come out as 0. One of the things I want to know is, yeah, the length has to be greater than or equal to 5. Okay. So if we query this particular range, it would give me back the answer 2. So I know for a fact that 2 is same, 2 is not same. So I don't know for sure which is what. So I can keep these two same and I can shift these two by 1. So 0, 1, 3, 4. So if I do a 3, 4, it would come out as 3. So I know for a fact now that out of all these indices, there is one in which there is there's a minority and there's a majority. Okay. Man, I have honestly no clue to this. I don't even know how to start thinking about this. What does this say? Problems like this suck. That's true. This one is very different from typical Leetcode, and it actually kind of makes it hard. Okay. By just reading it seems this problem might help little for interviews, but I actually played this game with my friend. Kind of fun. Can this be solved in less than overtime? Damn, that's tricky. So let's actually look at the editorial. A problem such as this, where your program has to communicate with the judge, is called interactive. We are not allowed to get a particular element from the array. We can only use a query function. An investigation of this property function is needed. Consider an example. Let's see. And see how the query behaves. 0, 1, 2, 3, because there are 3 elements, okay, and 1 element of this, okay. So you're trying a bunch of combinations for your indexes. Okay, this is going over my head, and I don't want to spend time on this one, honestly. I may take that up later on. Okay. And people keep on coming one after the other. Here, sir? People keep coming up one after the other. Sorry for that. Sorry for that. Okay. Let's go for this sparse matrix multiplication. Valid word square. Let's see if we can solve this problem. I don't see anyone who actually solved entire 100 problems. Only I can see this guy solved senior data center, AI building and scaling agentic genetic AI systems. Oh wow, okay. Guild process is part of this. So So he's still doing this, but he has only solved 67 till now. Hopefully I can solve more than that. Till now I have solved 29. Yeah. Okay. So given an array of string words, return true if it forms a valid word square. Given an array of strings, okay? A sequence of strings forms a valid if the kth row and reads the same string. So A, B, C, A, B, C. This thing and this thing. Okay? Mm-hmm. So multiple things at the same time. People will call you, people will ping you. You need to send something to your wife, you need to open the door for your cook, you need to open the door for Amazon. Welcome to life. Happens. Okay, cool. So one of the things we have to see here is that the kth row. So if you look at this, A, B, C, D, and B, N, R, T. So the kth row is the kth word itself, right? So we can just take the word, we can iterate over it, and then we can go over every one of the thing in here, and just take out that certain word. So as an example, this is 2. So second row, right? So C, R, M, Y. When you iterate over them, okay, check later. Streaming now. Okay. अभी लॉगिन नहीं हो, अरे यार तो चेक करके बाद में बताना क्या पिंग करे जा रहे हो. Okay, so coming back to the problem, you have C, R, M, Y, 0, 1, 2, 3. So you have to iterate over this, right? So when you get 0, what do? What do you do? So K is 2 in here, right? So what you have to do is 0 of 2, which is C. This is correct, right? Then 1 of 2. So this is R. So R is correct. So we have to go on matching like that. And if at any point either your character doesn't match, that is when you can say bye-bye. It's not matching, right? So I think this is just a true and false answer. Yeah, that's a true and false answer. So that should be pretty simple. 4, 2, 2. And someone last day pinged me saying that, hey, in an interview you solve on Google Docs, you solve on Notepad, you don't use an ID. Well, sometimes I kind of tell them that, hey, I want to use an ID. I want to use an ID because yeah, I mean, I can switch off all my auto completion and things like that, but then it doesn't make sense to keep on okay, anyways, so that's one. So here do we know? Okay, but yeah, I was talking about ID. So I kind of insist that, hey, I want to use ID because in an actual development environment you wouldn't be working with this thing. You're not working with like, you're not anymore working with those kind of systems where you have to go and SSH into the server and code there, and you're using a text editor like ed or vim. I hope you guys know what's a vim, ed. So that's your basic text editor. Okay. How do you quit? So the bindings are kind of like vim, but yeah, you don't see the entire buffer, you just see a little bit of it. But yeah, anyways, so coming back to the main problem. Okay, you're not able to. Okay, so int length is words.length, words.size. So for int k is this. So this is the kth row overall. String word is the same, right? For int I equals 0, I less than words dot size, word dot length I plus plus. Okay. So what do we do here? Here we say this character. First of all, we need to do a bounce check, right? We need to do a bounce check. As a matter of fact, I know कि इतना तो words होंगे ही, right? So I can simply do words dot get k. I know I can do that. String w. Let's do a bind. So if w dot length is less than I, by the side, we can simply return false right away. Okay. Or w dot char at I not equal to word dot char at I. Turn true. Did I do that wrong? I feel like I did that wrong. Yeah, that's more like it. If I'm right. Aha, I am right. Fuck you. Not right. Sorry. That's the correct one. Oh, we didn't do another check. ठीक है अच्छा. Okay, lonely pixel 1. Let's do the second one. So given an m into n picture, consider B as black and W as white. Return the number of black lonely pixels. A black lonely pixel is a character B that is located at a specific position where the same row and same column don't have any other black. Okay. Sorry. It's 500, not too big. Doesn't have any hidden question also. So I feel what we can simply do is we can iterate over every one of them, and we can have two different arrays of the same size, and we can say, okay, there's one thing to consider in here. It's an m into n, so it's not the same thing. It's not. It cannot be a square. A black lonely pixel is a character. It cannot be this, right? Or it can be. Because then this one becomes white, white, black, white, white, black, white, black. Black, white, white, white. So if I look at this, then here and here is only one. If I look at this, then here and here it's not the only one. Look at this, here and here is not the only one. And then if you look at this is the only one, so it has to be 2. So how do you do that? You can simply iterate over rows into columns. So this is white, this is white. How can we do this? So we can iterate over every column, and 1, 2, 3. So this column B is only 1. This column B is 2. This column B is 3. Okay, 1. So what we do is we take this B in here. So we need to know which column it is. So we can go like this. We can go like this. If B is 1 only, we can then iterate, and so we can capture the column, and then we can iterate over the column, and we can find, and since it's 500 only, it should be fair. Only thing here is that, so if there was a B here, I would kind of do the same thing when I'm iterating this row also, because when I'm iterating this part, I already know that it's like this, right? Well, one of the things we can do is we can always change B to certain thing, and then we can reiterate over again and mutate it back again to B. So I know that that has been processed and I do not need to do that again. That's one thing I would do. So we can do that. 531. So let's do that, I suppose. Okay. Cool. So we are doing an assertion that, yeah, so it will always be 1. So there's no way that this is an error, right? There's no way that this is an error. Okay. So what did we say we'll do? We'll iterate over everything. So for int, this is this, and this is row. This is columns. So you do that. Okay. Check for b in the row. Okay. So what you can do is this. If is this equal to b, then we can simply say c is column. But if c not equal to -1, which means we have already been set this thing, and we break out. Okay. If c equal to -1, you can just continue. Right. So this c in here is basically an indicator that if there's a single b or not, because at the very first b you encounter, it would set the column where you found it. And the next time, since the flag would have been switched, the value would have been switched, it is not -1. So why did you encounter it again? You're not supposed to encounter it again. So you reset the flag back again and you break it. So that also means that then now I can do a check that if it is -1, either you never found b, so that's why it's always -1, or you found it twice. You never found it once. So cool. Seems cool. So if you have found it 0, or if you have not found it one time, you simply go ahead and continue. So you just go back in the next row. If you did, what is the thing to do? So now what you have to do is, so you have found this column. So for int r equals 0, r less than rows, and in count is 0. Okay. If picture of row and column is equal to b, count plus plus. If count is equal to 1, int lonely is 0. Lonely plus plus. Is it that not the right solution? I feel that's the right solution, but I may be wrong. Not till now. Awesome. We did this, and it is row into column. It's row into column, right? Go row into this thing, and if you have certain thing, you again go. Yeah, so it's row into column. No, it is row into column plus row. So technically speaking, it would be row into row plus column, right? Because here you go with columns, considering a worst case scenario. So you have encountered one in every, you would go over every one of the single row again within that. So it's row square plus row into column. And usually this would be the predominant factor. Yeah, okay, cool. That's basically the solution. So how many are we? I think we are at 30. No, we are at 31. Okay, look at that. Did my name come up? No, my name still didn't come up. I don't know why. Why is my name not coming up? Also, it says 28 problems only. Right? That's all 31. Acha, weekly ranking. Weekly ranking. मैंने find out weekly ranking. Okay. So sparse matrix calculation. Let's see. Sparse matrix calculation is a interesting problem, I think. How is the stream going? No drop frames. Awesome. 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 The face is looking bad, weird. No, right? Okay. Cool. So sparse matrix calculation, multiplication. Given to sparse matrices, sparse matrix is something which is, most of the cells in the matrix are 0. Okay. Given to sparse matrices of length of size m into k and k into n, return this result of matrix this thing, you may assume that multiplication is always possible. Okay. So usually it has to be like if you're multiplying two matrices of m into k and k into n size, it would come down to m into k, right? That's what the usual mathematics behind it is. You can see that here. So it is 2 cross 3, and here is 3 cross 3, so it will boil down to 2 cross 3, right? And how it generally works is that okay, 1 0 0 1 0 0 minus 1 0 3 minus 1 0 3. Is this a sparse matrix? It's 3 cross 3, but yeah, I mean, whatever. This is definitely a sparse matrix with a lot of zeros, right? 7 0 0 0 0 0 is okay. 7 0 0 0 0 0 0 0 1. So in here 0 1 2 0 1 0 1 2 0 1 2. Okay. So like I mentioned, usually if you have 2 cross 3 multiplied by like a matrix multiplied by 3 cross 3, it would be this row into this column, the final result. So 2 cross 3. Okay. And the number of columns here needs to be the same as number of rows here. Otherwise you cannot multiply two matrices, but it already kind of says that you may assume that the multiplication is always possible. So we are going to assume that and move forward. Okay. Usually what happens here is that this guy would be like 1 into 7, like plus 0 into 0 plus 0 into 0. So this would be 0 comma 0. Then for this one, wait, did I do that right? Man, am I dumb enough not to remember matrix multiplication? I did that right? This into this, plus this into this, plus this into this. So what happens when I go to this here? What happens? Sorry. Yeah, that's correct. So for this row itself, which would be like this row itself, the first column would be the first row into first column. The second column would be first row into second column. Just like that. And also, what are we supposed to return? We're supposed to return a matrix itself. Okay. 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 So this is a little bit tough, I would say, because we need to efficiently store the matrix. I'm guessing it can be large. It's not large, it's 100. So why the fuck should I do all these things? Why can't I just do a simple multiplication? What about time complexity here? Space is not an issue. Space is not an issue. So you have to go over this row and this column. So you have to go over this row column number of times, right? So you have to go, so if it is m1 into n1 and m2 into n2, so for every n2 you have to go over m1, so m1 into n2, and you have to, sorry, hold on, my bad, this is the number of columns, right? So n2 n1 into m2, this is the number of times you have to go for a single row, and this has to be done for every single this thing in here. Is that so? I feel that's so, right? So what we can simply do here is that we go over this rows, which is m1. For each of them, we have to go over every column, n1, and we have to go over all the rows, which is m2. This is what we have to do. And I feel we don't really have to do sparse matrix multiplication with an actual hash tables and all that, because it's just 100. It's not a big deal. So are we supposed to do that? We can do a hash map, do a proper sparse matrix calculations, because most of them would be zeros. So maybe we don't want to multiply so many things, right? That's one thing. The other thing, yeah, so let's do that. So let's first, unwind the complexity. 311. Well, that's not how I intend to do it. So with Java, I feel it's gonna be a little more memory inefficient, because you have to create this wrapper. But then again, if you are with like this particular case, I don't see why it has to be a sparse matrix. You created a problem statement saying sparse matrix with 100 cross 100, so it's really not that big. But then if you have each row and column as 10 to the power 5, 10 to the power 6, 10 to the power 4, 10 to the power 3, 10 to the power 2, right, of that range, that kind of becomes a problem. 10 to the power 2 is already here, so 10 to the power 3 or something above, right? Because unless you go to 10 to the power 3, you're not going over the range of it. Currently the number of cells you have is 10 to the power 4, 100 into 100, which is 10,000, which is 10 to the power 4, right? Anyways, okay, so in here what I am doing is row 1 is this. Can you do that? Yeah. Okay, so now let's create a map of a cell and integer. We can call this a map. Okay, so for now, again, you need two maps. So I really don't know if this is worth the effort. You know what? I'm not going to do it in this way. Row 1, column 2, column 3. Intro is this, but let's call it 3. So now it has to be 2 cross 3. So like this. So for this particular element, I have to go over this thing and this thing. For this particular element, I have to go over this thing and this thing, right? So for no, how do we do that? Hold on. This is again 3. You know what? Int row 3 is equal to row 1. Column 3 is equal to column 2. Okay. So now I'm iterating over these things, but for this value I need to first iterate over this. Okay. So mat1 of this row and C plus, so when it was 0, you always take this column, right? So mat2 of C and wait, do this right. Hold on just a second. I don't want to do a stupid maths here. So I want to go like this. I want to go like this. Yes, sir. Yes, sir. It has to be the column. Yeah. Correct? I feel that's correct. I may be completely off, but we will see. I don't use row 2 ever, which is kind of worrying to me. Yes, it's kind of worrying, and that's correct because it's not going to be column, it's going to be something from row 2. Man, I hate matrix multiplication. This is wrong for sure. It's going to give an index out of bounds or something. Yeah, it's wrong. It's wrong. It's wrong for sure. Okay. So let's just think it carefully. So let's remove this shit. So you have this. Then you also have this. So for this guy, so the final result would be 2 cross 3. So for 0, 0, you have to first say 0, 0 into 0, 0 plus 0, 1 into 1, 0. That's what you have to do. Plus 0, 2 into 2, 0. For the second one in here, you have to say, so this is, the second one is the column that we represented as column. So we have to go and capture the column thingy. Gotcha. Ready. If I'm right, that is what we have to do. And if you're wrong, you're wrong. You're motherfucking wrong. I don't want to solve this problem right now. Like it's some more brain strenuous problem, and I don't want to solve it because I almost have half an hour left before I have to get ready to go out. So I don't want to solve this, to be very honest. So fuck off. I'm gonna try to solve some other problems. Which I know I already solved before. Meeting rooms I know I solved. So meeting room I solved multiple times. And I'm going to try and solve that. Given an array of meeting room intervals, determine the person could attend all the meetings. So, so you have 0, 30, 5, 10, sorry, 5, 20. Yeah, the very simple thing is, so you have only this, right? Okay. Sort them. Was my problem statement already typed? Yeah. So I can just kind of copy paste. I'm going to copy paste. I'm going to type it anymore. Sort multiple times. So you sort them first using the start and then using the end. This is in case if you have duplicate starts, right? Sorry, duplicate starts. And you can just consider the first end time. And then you start iterating from the first element. And if you say that, okay, if the start is less than the end time, it means you cannot attend everything because there's an overlap. Otherwise, you just update your end time and you just move forward. So that's basically it. And I'm going to copy this in here. And I'm not going to type this again. So this is just increasing the number of count. And it's a little bit slow because I'm pretty damn sure. Oh, they still did. Okay, but here's one more thing. They didn't do a comparator. No, they did a comparator. So I don't know why they are still. Maybe if I submit it one more time, it's gonna be a little bit slower. No, apparently not. No, look. 9 milliseconds, 9 milliseconds, and all that. So if I go to submissions, where do I? Okay, if I just submit this. Yeah, there's 6 milliseconds. I mean, kind of the same thing. But anyways, okay. We can also try and do meeting rooms too. And what is the problem statement? Given an array of meeting rooms interval, return the minimum number of conference room required. So this problem, I want to do it again by hand. The reason why I want to do by hand is that this is another problem which is kind of like a more classical problem in an interview. And maybe if someone is watching me and want to learn how to do it because like you want to get a refresher or you don't know how to solve it, so this might be helpful. So this here has different variants of problems again. Somebody asked number of train stations, but the problem statement is very simple. So you are given certain intervals of arrivals of train or starting and end of meeting rooms and all that, right? And what you have to do is you have to find a minimum number of rooms that you require to accommodate all the meetings. Okay, that is what the problem is. And yeah, so usually what I do is the very first thing is it doesn't quite say that when is the overlap, right? So usually in a real life, if something ends at 10:30, you can start a meeting at 10:30, but does the problem statement require you to do so? So I simply go ahead and do it in this way. A test case. That's very, very simple. So I just start a meeting at 30. I end the previous meeting at 30 and I start the next meeting at 30. So if you see here, it would most likely say 1, which means that like cut to cut boundaries overlap is okay, but you cannot have an overlap where something starts at 29, right? You cannot have that, which means that, yeah, you need a new meeting room. So it would be 2. So what I like to do here is that, let's take an example of this, okay? What I like to do here is that split. Even with the train station problem, I do the same thing. So I try to split the start time and end time. So all of the start times together is 0, 5, 15. Okay, so this is a different array. And then I sort them. So 0, 5, 15. Well, my handwriting is mashallah, but 15. Then you have mashallah. Oh, fuck. Okay, so then you have 30, 10, 20. I'm learning language, huh? I think I was watching a reel where I learned this word. But anyways, so I sort this also in sorting order, even though they are not kind of, like the positioning is not going to be corresponding to the start times. It really doesn't matter. I'll tell you why. So 10, 20, 30. Then I say there are two things that you need to track. One, total. This is the total number of meeting rooms that I need. And empty. Is any meeting room that you have already allocated? So let's say you have built a room. Is it empty? Can I accommodate a meeting there? So that's why empty. So to start with, what I say, the meeting start is 0. Like you already considered this. Okay, you already considered this. Sorry. So total in here is 1 and empty is 0. This is your starting state of the program. Meeting start is whatever the start 0 is. For us, it's 0. Weird timing, but yeah, just go with it. Okay. The next thing I do is this is where you start your pointer. So I and j, because you already considered this, right? So you don't have to anymore take that into account. So I and j. So the next meeting starts at 5, right? The next meeting starts at 5 and something ends at 10. It really doesn't matter what ends at 10, but something ends at 10 and you have to start a meeting. So you'll go ahead and look, is there an empty room? No, which means I need another room. Okay, which means I need another room, and you move the pointer here. Now you see 10 is less than 15 in here, right? Less than or equal to. So I can end a meeting. I move the pointer up here and I say, oh, total is 2, but now I have one empty room because I ended the meeting, right? I ended the meeting, so I have another empty room. Now the question is, 15 is less than 20, which means I need a room. But now, before I allocate another room, I want to see, do I have an empty room? Yes. So I'm gonna make this 0 and I'm not gonna increase total. So the total thing after that, so because you ended this thing, right? Ended all the meetings to start with, you really don't care now when they end. So you can stop your loop, you can stop your iteration, and you can see here, this is what you need to do. So that's basically the problem solution. You segregate out the start time and the end time. You sort them by their integer value in an ascending order. And then you always say that, okay, I will start the meeting. Whatever the first meeting is, I'll start. So you do start the meeting in this one. So you say total, though I need 1, and there is no empty rooms right now because the meeting has started. And then you start iterating from I equal, like the first position for the start and 0th position. You will end a meeting. You will end a meeting and increment the empty count only when your current pointer at the end time is less or equal to whatever your current pointer of the start time is. If your current starting time is less than the current end time, you would first check if you have an empty room. If you have an empty room, you would decrement it. If you do not have any empty rooms, it means you need a new room. So you would allocate a new room. So this is what the entire problem is, how you would solve this. Let's quickly code it up because we have 15 more minutes. Maybe, I don't know, because my wife is still not back and we are supposed to go out. But okay. So let's quickly go ahead and do that. So we can do, we can do some functional programming in here. Arrays dot stream of intervals. So you're gonna map array of 0 to array. So of course here you can say map to int. So start times and end times you can say like this. One of the things you can do here is dot sorted. So you don't have to again. Okay. Next thing is, how on earth do we do? So let's just follow what I just mentioned. I mean, no one can read this stupid thing that I've written all over, but let's try to decode. So we already said कि starting point तो ये लेना ही है, right? So int total is 0, 1, and empty is 0. Int I is 1, j is 0. So I is the pointer which lets you iterate over the start times, and j is this one. Okay. While I is less than start times dot length, you don't have to give this, because like I mentioned, this will go out first for sure. Otherwise your input is wrong. So if start times of I is less than n times of j, if empty greater than 0, empty minus minus, else total plus plus. And here you have to move this pointer. Else empty plus plus. That's all. Turn total. And I think that should be the problem. That should be the solution. How is the stream going? Stream is healthy. Okay, cool. Oh, look at that. 12 people logged in. Good. Time limit exceeded. Oh, I didn't do that. That's fine. Now it's a little slow. What is one of the ways to make it faster? Let me show you. Intervals dot length. This should be a little faster. It's not about like we are doing map twice in here. I think you can do a multi-map or something like that, which will basically, split it out into 2 different arrays at the same time. But yeah, you see it's already 1 millisecond. The main problem here is that you're working with unboxing boxing, so that kind of becomes a pain in the ass to work with. Yeah, so that's basically it. Okay. Cool. Okay. So I think missing range is something I tried to solve and I couldn't solve. Okay. You're given an inclusive range, lower to upper, and a sorted unique integer array nums where all the elements are within the inclusive range. A number x is considered missing if x. Just give me a second. I need to just be back. Just give me 2 minutes. Yeah. Okay, we are back, but I don't know for how long. Let's quickly see. Okay, you're given an inclusive range, lower, upper, and a sorted unique. You're given an inclusive range, lower, upper, and a sorted unique integer array nums where all the elements are within the inclusive range. Okay. A number x is considered missing if x is in the range and is not in nums. Return the shortest sorted list of ranges that exactly covers all the missing numbers. Okay. That is, no element of nums is included in any of the ranges, and each missing number is covered by any of the ranges. So you're given certain numbers, and then you're given a range of lower and upper. So from 0 to 99, all of these numbers are present, inclusive. But then whatever is missing, you have to generate the range of it. So 2, 2 is also a valid range because 3, okay? Okay. Oh, ha ha ha. And it's a list of integers. Okay, so that is pretty good. I think this can be simple. 0, 1, 63. I swear to God, if someone knocks on the door right now, I mean, someone will, because my dad is out. But yeah, every 15 minutes there's some. Okay, so one of the things we can do is set. Okay. So this will give us a quick lookup, and yeah, it's set. Okay. So for int is lower in this thing. If it doesn't contain this number, it means the range starts. Right. It means the range starts. Okay. It means the range starts in here. So one of the things we can do is while this thing. So then it kind of becomes easier to manipulate I. Right. So int start is I, while I is less than upper, and set doesn't contain this I++. That's all. Next, we can say list of missing ranges. List of start and I minus 1. The only question here is, so here it's always over by 1 where it's already present. That is why it did that. So I can skip over here also. So even if something was not missing, you skip, or if something was missing, I would land at a position where set contains it, or either it's less than equal to upper, upper plus 1, which means that even if you do this, it should be fair. So that should be the solution. Previously I did it in Python, all memory limit exceeded and all that. So let's see. Time limit exceeded. So you cannot do that. It's okay. It's 10 to the power 9. So just going back to our thing in here, it has to be log of n or O of 1. Okay. Sorry. That is sus. So it fills in here. Okay, where you have to actually. So what if I just run this like this? It will still work, or it will still time limit exceed? It's still time limit exceed, but I don't want to see if the solution is correct or not, right? So one of the ways I can see that is new. Well, let's make this static and say find missing ranges. So this is this 0, this is this, and I hope there is no program which is kind of not finished. Okay, so this is correct. This is what the expectation is. This is correct. This is what the expectation is. But then and a sorted unique. So we are not taking advantage of the fact that it is sorted. You know what we can do? You don't have to do that. You can do it in a different way. So let's do it in a different way. So let's take this example. So the very first, why is it not working? Okay. So the very first thing we can check is with the first number. So 0 to this thing. Is it same? Yes, it's same. So we don't care. We move on with the iteration, right? So we are here. Sorry, we are here. We start from 1. Start from 1. So once we start from 1, we say, oh, can it be 0? Length can also be 0. Okay. So let's do these things first. If nums.length is 0, turn list of lower upper. Okay, that's all. After that, we always start from here, and we know 1 is included. So what is not included? Nums of I minus 1 plus 1, nums of I minus 1, and then we move to the next one. This is how we can do it, right? So for int, so let's first do what we mentioned. If so as a matter of fact, we know 1 length ahead, right? So if nums of 0 is not equal to this, missing ranges list of lower and minus 1. That's the first range missing. Then we can say for int I equals this. Okay. if nums of I not equal to nums of I minus 1 plus 1. So if it is not a sequence, yes, that's basically it. But then you also have to check with the higher stuff. So if nums of length minus 1 plus 1, sorry, not equal to upper nums dot length plus nums dot length plus 1 and upper minus 1. So that is what the solution should be.